Hope my screen is visible. Can someone confirm, please?
Yeah, sir.
Is my screen visible? Okay, thank you. Hope I am audible also. Let's start. Okay, I hope everyone have created your project in RStudio, and we have seen a data set, and I have pasted that data set also in the chat window last time, and you might have gone through it. Okay, let's open my project. So if someone who have joined only today, kindly create a workspace in RStudio Cloud and start using it for learning. It's taking too long time. There is a very good article on how data analytics can be used for industry. Okay, and I request you can also go through this particular article when time permits. I will just give you a gist of this particular article. This is published by the Industrial Internet Consortium. Okay. Industrial Internet Consortium is the association of many organizations like ABB, Huawei, Vimana, and other things. Okay, so you can see here, these are all the editors who have pitched in and they have contributed, like National Instruments. There are a lot of people who have contributed for this particular standard. And this was published in 2017. Okay, we are at 20, but anyhow, but it makes sense. It makes sense actually. Okay, what these things talks about is how high-speed data we can take inside and we can start using it. Okay, because what from industries, whatever data we are talking about are high-speed data, and the data comes at a greater speed. And this talks about both the business perspective as well as on the technical perspective. So I request everyone kindly go through this, and they have also done some interviews with the top executives, and they have listed down what would be the emerging technology in the future, and which technology is something that executives want to go immediately. Okay, and in all these things, predictive analytics is coming in the forefront. Okay, so analytics plays a very important role, and I would suggest, like at present, this is a very good book to start with, because no good books are available in this particular regard. Okay, and very important is edge analytics. They advocate more on edge analytics, and they also have given a deployment strategy how this particular things can be. Okay, so this is a very good book. I have already pasted this particular link in the chat window. Kindly go through it when time permits. Okay, on coming back to our topic, how many of you have created an RStudio cloud username and password and have done some work? Can someone raise your hands? Have you done any such work? Can I construct? Can I create a poll here? Don't think so. I don't think so. So this is one of the things what I want to introduce here, because many times we don't so hope you're able to see this particular screen, right? So can you all just put the votes? Okay. Have you done at least one project in RStudio Cloud or desktop? Okay, go to www.mentimeter.com and use the code 282791 and cast your votes, please. All students, please do it. I have a feedback from your staffs that the session have to be interactive. So we are planning to use this particular tool for that. Okay. Use your mobile. Go to www.menti.com. Okay, no, very good. Frank answer. Yes. I can see there are a lot of no's, only few yes. Friends, thanks for the frank feedback, but I think you have to have hands-on. Okay, so kindly go to RStudio Cloud, create a project, put some effort, and try to learn. Okay, so we are giving the codes also to you. Do you think like it is not useful, or what you want us to do to improve this? No to yes. Any suggestions? You can unmute yourself and please give a feedback. Any suggestions? I think last time we gave you the code also, right? You are facing any difficulty in signing up to RStudio Cloud or something like that?
Yeah, sir. Myself, Ravi Malik.
Yes, sir. Yes.
Yeah, actually, I have joined first time this chat.
Yeah. No problem, sir. No problem. But for people who are following up, are you facing any problem, or maybe this is our 10th session, I hope. Okay, so are you facing any problems in logging in into RStudio Cloud or something like that? Do we have some problem, or it's not a problem? Can I have some answers from the BIT students, please? BIT students, any feedback, please? BIT students? Okay, then that means like you can do it, but you are not getting time or something like that. Kindly do it. Hands-on is the only way out. No silver bullet for this. You cannot learn all these things in a college or in a course or something like that. Obviously, that will be only a teaser. They can only show you what is possible, but you have to put your hands on and see what is possible with the data. Okay, again, we are also giving you the data also. So with the data, kindly put your hands on and do the things. Okay, fine. So for the benefit of everyone, okay, see, this is the RStudio Cloud, and this is how the environment will look like, very similar to the desktop environment. You can browse it even in your tablet or something like that also. Okay, and we have done some examples of how this particular data can be used. One of the data what we were using from the last class is this particular data, which is part of a book actually. Okay, if possible, you can also download this book and you can read it. Okay, I'm just copying and pasting the link of this particular book. Okay, it's not the book actually, it is in GitHub that the author have published his data set. Okay, this is a very welcome one. I suggest, like, please everyone go through this particular data set and see how this particular data set can be used. Okay, so this particular data set, if you see, it is having 1,19,296 rows of data. Okay, 1,90,200 rows of data. Okay, and this data, okay, so this data is from a solar power plant. Okay, solar rooftop solar, and from the rooftop solar, the energy is going to a battery, and from there it is going to an inverter, and before inverter, after inverter, like that. There are a lot of dimensions. Okay, so what we will do is we will first explore the data. One is, let me see the data. Okay, I'm just opening the data here. Okay, you can see here it is from a location Peru, and this is the date and time, and this is the solar voltage, solar current, solar energy, solar power. And from the solar power plant, there is a battery connected, and the battery voltage, current, and the power, it is also there. Load, you can see here, load energy 1. There are 2 loads. Okay, load energy, load 1 energy, load 1 power, load 1 current, voltage, load 2 energy, power, current. Okay, and then in between the battery and the load, there is an inverter. Okay, so there is an input power from the inverter and an output power in the inverter, and the input energy and output energy, like that, it is given. Okay, and the final thing is the irradiance and the temperature in that particular area, that is also given, okay, to us. Okay, so with this we have to we can do multiple things. Let me see what are all the things we can do. Okay, so any doubts so far with the data? So I suggest, like, you also download this particular data into your R project. Okay, please first open the R project. What we are seeing here is very unhealthy. A lot of people are not exposed to R. Okay, kindly be comfortable, install R. It is an open source software, free software. Kindly install it. If you have some doubts in how to use R and other things, we have the recordings in the YouTube also of this particular program. This is the 10th session. Okay, and you have a lot of recordings also. You can go through it, and there are enough public videos available on that. Okay. But on energy, I think we are focusing more. That is a good point from IAEMP, and thank you, IAEMP, PSG volunteers who have helped me to compile these codes, and the Banari Amman Institute of Technology, who is asking their students to take this particular course as part of their internal things. Okay, thank you so much for all these things. Okay, so first the basics of the things. Okay, I have seen dim is a command used for seeing the dimension. Okay, dim within bracket data and summary of the data. This is a row comma column, so I'm keeping the row. That means I'm not giving anything in the row. That means I want all the rows, and the 3 column 6. That means from the 3rd column to the 6th column I want all the data. Okay, that is what I'm seeing, and I'm asking it to give me a summary of the particular data. So what are all the columns? It is a solar voltage, solar current, solar energy, and solar power, and this is a numerical data. So whenever the numerical data is given, then it will give something like what is the minimum, what is the maximum, what is the median, and what is the mean, and first quartile and third quartile. These are all the informations it will give. Okay, so don't worry if something is hard for you to understand, no problem. Just follow, use this particular course, do the exercise. Automatically you will understand what is this and why this is required. Okay, now in R there is an advantage as well as I would say, like, it is a very important point. What you have to do is create a formatting of the date and time. Okay, create a format of date and time. Just a minute. Okay, so sorry for the interruption. Okay, date and time is a very important aspect which we have to see, and we have to format it. Okay, so there are this Lubri data. Lubri data is a package. Okay, this Lubri data gives a lot of options. One of the option it gives is to format it. So the date and time column, if I want to see, okay, you can see here. It is already formatted, but what I am telling to R is this is available in this particular format. Okay, so I am saying like it is year, month, day, underscore, hour, minute, second. Okay, so I am creating that as a format. Okay, now I have created the format. Okay, the data is available with me. Okay, and what I can do now is now I have this particular data, and I can do slicing operation. That means like I can do like each and every month how much is the energy it has calculated, it has consumed. Each and every day how much energy it has taken. Like that I can do lot of activities. Okay, so one of the activity is if you ask me, like once the formatting is done, then you ask what is the minimum in the date column. Okay, that is the from date. Okay, from 2015 12th month 02, from 00 hours 27 minutes onwards I have the data, and the data is available till 2016 third month, that is March month. So almost 4 months of data is available. Okay, and if I ask the length of the data, it is saying 104. But if I have this particular difference in time, okay, where as I have formatted already the data, I can now create a difference of time, and you see the difference of time. It will say you can see here the dates. If I count, then it is 104. But if I ask the difference of time, it will say exactly 103.935 days. Okay, that means it is going into the seconds. It is going into the minutes level. Okay, that is the advantage of formatting. Okay. Next is I want to see what are all the columns available. Okay, I am splitting the data set. So the solar columns, like that I am splitting it, and I am asking R to take only the data from the solar power, solar voltage, and solar energy, and solar current into one data set. Okay, so I can call something like 3 column 6. That means the 3rd column till the 6th column you give me the data of summary. That is also possible. Otherwise I can create this particular vector like this, and from the vector I can also call it. Okay, so that is the 2 variants. What I would say, you can either go for these kind of addressing, or you can go for the absolute addressing with the name. That is also possible. Okay, with this. So that is the another thing. Now if I plot the solar voltage, you see here it is giving me the data of say the entire entire 4 months. Okay, but with this I will not be able to make any sense out of it. Okay, so now for descriptive analytics, which is the first one, what I want to do, I have to subset this particular data for one day, and I need to understand how this particular data is. Only then I will be able to extrapolate and use it for next other things. Okay, so in that particular perspective, what I am doing is I am creating a split of the data. For creating the split of the data, I am asking only the first day, that is the December 12, 2015. Only the data of that particular day you give me. Okay, for that, what I am doing, I am creating a variable called day, and I am using that for slicing. You see what I am doing now? I am taking a subset of the data, and the subset of the data, it's very easy in R. You have to call the data, use a square bracket. After that, date, which is the column of that particular date and time vector. Okay, so as I have already formatted into as I have already formatted that particular column into date and time, now I can use the keywords like date here. Okay, if I ask date, then what it will do, it will give only the date from that particular column, not the time. Now, next filter, what I am applying is whatever date it is coming, you filter it to the day variable. The day variable is what? December 12. Okay, so December 12, only that particular date you filter and give me. That means all the rows here. What I am doing, all all columns, but only the row which is containing the date which is 12/12/2015. Okay, so you can see here I am using all rows but all columns. Okay, so after the comma I am using it, row comma column. Okay, so row comma column. Here I want to filter with respect to row. That's why I am giving in the first, before the comma I am giving it. Okay, now I am I have already splitted it. Now I can plot it and see how the variance is. Okay, you see here, now I will be able to see how the variance is. Okay, so the voltage is building up maybe after some time, and then it is getting stable and it is coming down. Okay, so that is the split what I am going to do. Okay, now I can also see how the data is also appearing. You can see one of the thing is I can also see how the box plot of the data, that is a distribution of the data. The solar power, the median is almost 0. That means majority of the times there is no production. That is when the irradiance is less. Okay, after that it has started production, so that is the distribution it is coming here, and here it is a positively skewed distribution, and you have solar voltage, solar energy, and solar current. Okay, when you normalize the data, what you will have, you will be able to see the exact spread of it. In the last class we talked about this normalization also. Okay, and next thing is what we understand is the energy is an instantaneous energy they have captured. That means every minute how much energy it has taken. Okay, but what we will be interested, maybe when we are plotting, we need the cumulative energy. So what we have to do, we have to do a cumulative sum of it. Okay, so there are some very good things which is available. Okay, for creating a cumulative sum of things. Okay, we will see it in the later things. Okay, so now we have created a plot which is a basic plot in the feature of R. Okay, but there are very good libraries called ggplot which can give you a very good plotting. Okay, so one of the plot here, you can see here, when you use the ggplot kind of command, you can have the date and time in the x-axis, and in the y-axis you can have the voltage. That is also possible. Okay, so you can see here it will give a very neat plot. Okay, that is possible, and there is one more package called Plotly where you can also zoom in, you can play with the plot. Okay, so it is a dynamic plot. And there is one more thing, like, so now in the before we see how the voltage is, and now let me see how the current is. Okay, you see here now the current, how the variation is, it is also here. Okay, so probably here there is a dip, I don't know, could be a trip in the inverter or something like that. Okay, and next is power. We know, like, it is a product of voltage and current. It will also follow the same graph. Okay, now energy. That is also you are able to see. I hope you will be able to see in the right hand side bottom how that particular column is coming. Okay, and now what I have done is I have created a cumulative sum. You see here what I am seeing is sample. Okay, sample is the only the solar. Okay, related columns. I'm taking it as sample, and I'm creating a new row called solar energy underscore cumulative sum. Okay, then there is a keyword called cumulative sum. If I use it, then it will, what it will do, it will accumulate and it will show me the data. Okay, now once that is done, then for energy we can create a very beautiful plot like this. You can see here the energy till 6:30 it is not generating. That means there is no consumption. After that, cumulatively the energy is getting consumed, and we are able to see the cumulative sum of it. After say in the evening 6 o'clock, after that you will know like the irradiance will be very less. There will not be any production in the solar. Then after that it is stable. Okay, so this is the cumulative sum, how it can be used. And now we will go into much detail. Okay, one is let me see each and every date how much is the energy it has taken. Okay, so what I am doing, like how I have created sample at solar energy dollar solar energy underscore cum sum. Okay, cumulative sum. I'm creating one more row in the data column. Okay, data column is the master data. Okay, in that I'm creating one column called date. Okay, what I have to do is I have to just use the date and time column, but I have to eliminate the time. I have to use only the date. Okay, there is a function called as.date. With that I can do this. Okay, you can see here. Now I have created this. Okay, now if I go to the data, okay, there will be one more column in the last, which is the date column, which contains only the date. Okay, so here you can see this is date and time. From here I am taking only the date to the last column and I am using it. Okay, so now I have the date. Okay, now what we will do is every day how much energy it has taken. Okay, that I have to I have to cumulate and I have to see. Okay, for that what I'm doing is I'm creating a another variable called new. Okay, so, and there are beautiful functions. Why R is being used, you have to understand. This deep learn package is giving one function called okay, you can see this is called the pipe function. Okay, so just imagine this is like a pipe. Okay, pipe. Okay. So data is the I would say the tank. Okay, so from the tank, which is data, which is having all the data, I am creating a pipe. Okay, and from the pipe, what I am doing is next I am taking this particular data with the pipe. I am doing an operation. What operation I am doing? Group by. Okay, and what I'm asking is group by with respect to location. That is, Peru can be one location. I don't know, in this particular data there can be some other location also. So I am grouping all the data with respect to the location and date. Now I have grouped it. Now next I can also do the second thing. Now I am putting one more pipe. Okay, this is the pipe symbol. Okay, percentage greater than sign and greater than sign. This is called pipe symbol. Okay, after that what I can do is whatever grouping you have done and split the data, you summarize it. Okay, each and everything you summarize it. How you have to summarize? You create one column called total S energy. That means solar energy is equal to sum of solar energy. Okay, so let me just format it and show you. It is a very good function. And just imagine for this you have to do it you in Excel and other kind of things. It will be a hell lot of tasks. Okay, so you here is the water in the tank. Okay, then from there I am taking the data. I am splitting the water into location and date. Each and every date I am taking the data out, and from there I am creating a summarization, and in the summarization I am using the total solar energy is equal to cumulative sum of energy. Now if I execute this, okay, control and enter after placing my thing here, then I will have some data called new. Okay, new. Okay, then if I go into the new, okay, you can see here there is a location, there is a date, and there is a total energy. Okay, now I can also do some filtering exercise here. Okay, so let me see whether anything else is there. I don't know. I think it will be only Peru. There will not be any other thing. Okay, it is completely Peru, nothing else. Okay, and this is the date column. Okay, and I have the total energy column. So like that, I have all the things here. Okay, as a subset of the original data, subset of the original data. So we have 104 days. Okay, so 104 days. This is the tail. Okay, 104 days till March 14, 2016. This is the cumulative energy for each and every day. Okay, so now we have this particular thing. Now let me see in the graphical view how this particular variation of total energy consumption is there. Why variation have to be studied? Why variation in total energy have to be studied? Any answers? Any answers? Okay. Kindly unmute yourself. Give me some answers. Okay. Now what I have done is the total energy with respect to each and every date I have just plotted here. Okay. What you can make sense out of this? Mr. Ravi Malik.
There are some anomalous readings.
There are some anomalous readings. Okay. Anything else? Can someone give some more insight? Alaganand, can you give some insight about this? Alaganand, Arjun, Bharat, Bhunesh. We have Kavi Priya who have just joined. Students, can you give some insights about this? Okay, in the left of your screen, I hope you are able to see my screen, right? Left of my screen, you have a graph, okay? That is every day, the energy production, okay, from the solar power plant, and what is that you are seeing, okay? Anything? Harinath, Hemshri, do we have any students from MCT, Mahalingam College of Technology? Please unmute yourself and speak. Darshini, Dinesh, any comments?
So weather related incidents.
Yeah, you can see like if there are any drop in energy production from the solar power plant because of weather influence. Yeah, very good, very good. Anything else? Any other insight? Please put your technological hat. Okay, put an hat like you are an electrical engineer. Now you think about it. Why we have to monitor this? Why we have to see the variations in the energy production of the solar power plant every day?
So that
What are the other things which will impact? Yes, please.
So that we can study and try to reduce the variations, make it as remove any external influences causing change.
Yeah, what would be the external influence? That is what I want to understand, sir.
Okay.
What could be the external influence? One is weather. I think somebody have mentioned about this already. Okay, what other things?
I only mentioned.
Can I have some more response from students, please? What are all the other influences the solar energy would solar energy production will have an impact on? Students, if you are comfortable with your own language, no problem. You can speak in Tamil, Kannada, Telugu, Hindi. I will try to understand, but please respond. Or do we have someone else who, other than students, who wants to give their opinion? Why we have to see this particular energy production, okay, and make a track it? Why we have to track it? And what is this line, red line in the graph? Any input on that?
Quartile lines.
Yeah, quartile lines. Yes. So that is the quartile 1 and quartile 3. Oh, sorry, quartile 2 and quartile 4. So this is the I would say like this is the 50%, sorry, 75% of the total population is residing between these two lines. Okay, anything above that or below that, that is a concern for us. Okay, in energy analytics, what we have to do, we have to see significant variation in energy consumption. Okay, and we have to take actions on it. Okay, so this particular thing gives us an opinion on how this particular solar plant is performing. Okay, another important factor why we need to keep a tap of it is the maintenance. Okay, these solar plants, if I don't know in Peru what could be the condition, but if in India or in some cities you will have dust accumulation. Because of the dust accumulation also you will have very less production of energy. Okay, so you also have to keep a tap of it and see how the things are after a maintenance, how it is getting improved. All these things you need to keep a tap of it. Kindly see, what we have to do is we have to frame an hypothesis, and for the hypothesis we have to validate it with data. That is what data analytics is all about. One of the hypotheses here is whether the energy production what I'm getting, whether it is in line with how much is the irradiance, or is the solar panels is doing justice for what it is being installed there. Okay, that is what we are seeing here. So one of the first thing what we can do is how this particular energy production is. If there are significant drop in energy, okay, this can be a cloudy day. That is also possible. You will check it maybe on this particular date what has happened. And at the same time, if it is not a cloudy day, then you can make a sense like it could be a malfunction in the inverters, or it could be maybe dust over the solar panels kind of things. Okay, so that is the reason we need to keep a tap of this particular generation. Okay, unless otherwise we don't watch it, then we will not be able to take any action out of it. Okay, so let me see how this particular line is being drawn. Okay, this is the ggplot function. Now tomorrow you are using the same code, but for a different data point. I want to tell you where and all you have to make the changes. Okay, so first thing is the new is the data. Okay, so new is the data column, and x is the date column. Okay, and y is the total energy column. Okay, and you are giving the color to that particular line. Okay, that is the blue, and you are giving a size to that particular line. And after that, you want to read, you want to put the upper control and the lower control, like red. That is the upper control and lower control. So how this red you can do is okay, interquartile IQR. Okay, new solar total energy. If you ask, then it will give the interquartile range. So the interquartile range is 1.63. Okay, so 1.63 is the interquartile range, and with this you can make a. Then now you use the summary function. Oh, summary function is already there. Okay, summary function. You can see here the first quartile is a 9.275. So according to me, this has to be 9.625, and the third quartile is a 10.905. 10.905 is my upper limit. Okay, so this is how my lines have to look like. Okay, so this is my, I would say, like if I put the quartiles, then it will be something like this. Now you will be seeing there will be a lot of things which is coming out of the spec. Okay, so this is one way of seeing it, and another way is whether there are some variations. You can also do the box plot of it. So in the box plot, you can see here there are a lot of outliers in the bottom. Okay, outliers in the bottom. You want to identify when this outlier has happened, right? So this is nothing but in the summary you have something called minimum, right? 4.960. Okay, so this is the minimum 4.960. If you put 4.960 and the maximum is 13.020, if you create a plot with this, then you will be able to see the outliers. Okay, there is an outlier here and there is an outlier here. Okay, which is almost touching the minimum and the maximum line. Okay, so this is how you can also see whether there is some outliers also. That is also possible with these kind of graphs. Okay. So, but ideally, when we are creating the limit, we normally create the limit based on. We normally create the limit based on the first quartile and the third quartile. First quartile and the third quartile values. Okay, that is how normally we will see, because we want a very less amount of variation in the data. Okay, if you reduce the variation itself, that is a very big advantage. Now we have explored the solar plot. Okay, solar energy thing. Okay, do we have to see what is the voltage, what is the current, what is the power? See, I think the best deliverable of a solar thing is the energy. Okay, that will give us the best. I would say the best output, or it is the indicator of the condition of the solar plant. Okay, now let me go to the energy. Okay, so in energy there are important points which we will explore and we will see. Okay, this is the second step of analytics. So what we are doing is we are doing a diagnostics of what is happening in that particular field. Okay, so the thing is load energy 1, that is load 1 energy, load 2 energy, and the inverter input energy. Only these three things, let me do a small study of it. Okay, again here, whenever you are doing a study, kindly see the split of it. Okay, how it is, and then you split for 1 day. Okay, the same what we are following for solar. Okay, 1 day, and see how the data is. Okay, I want to also add let me also add the inverter output energy, because in why this is important, inverter efficiency you can make out of it based on this particular value. So I'm creating a subset of it. Okay, so I'm creating a subset of it, and I am seeing how this particular thing is. Okay, so load on energy, the cumulative sum of it. Okay, inverter, and we have added one more. Inverter 1, sorry, inverter input, right? And we also want the inverter output, right? So let me add this inverter output also. So see, I want to just show you how easy it is for customizing. Okay, if you have this particular code, you can customize and you can create your own hypothesis and you can start testing it. So let's create inverter output also. Okay, now Another important library which I want to introduce you is this particular Reshape library. Why this is very important is when you are having a lot of data with you, you need to reshape the data. Like in the deep layer, we used that particular pipe function, right? The same way, there are other ways of doing it. I want to just introduce you to the other ways. That's all. Okay, nothing new in it, but there are other ways of doing it. That is what we want to learn from here. Okay, so let's do the similarly how we did the pipe function, same. Okay, here I am taking the sample data, then I am giving instead of the group by, I am giving it, here is a date and time. Okay, and these are all the measures and these are all the variables. Okay, so now I am asking it to melt. Okay, when I am using this particular function called melt, what will happen is this will convert the wide data into long data, This is a function. Okay, why this is important, you will understand. I'm sorry. Press function F1. You have this particular melt. Melt is a function which converts the data structure. Okay, so you can convert the data from one structure to other structure. Now let's see how this sample is. Okay, this is the sample what we have. Okay, what is sample? Okay, this is the sample data frame, and in this particular data frame I have location, date and time, solar voltage, these things which we have done in the first part of the code. Then we have added this load one energy and other things, and I have taken only the data of this particular date, that is 12/12/2015. I have taken it. Okay, so this is how my data is. It is like in a wide format. Now after melt, just see the shape of the format, which is A, which we have to follow. Okay, let's see how this becomes. Okay, now I will open. See, you have seen the sample file was having how much? 28 variables. But here I have given 1, 2, 3, 4. Only 3 variables I wanted to split. Sorry, 4 variables I wanted to split and convert into a different dimension, which is a long format. Now you can see here the number of rows is 1170 observations. Here you will see 4680 observations. Okay. Now let me see how this particular melt function is. You see here what has happened for each, and instead of putting the variables in the top, it has put the variable in the column. Okay, the variable name in the column, but the value it is keeping. Okay, value it is keeping as one column, but for the same date and time, you may have 3 variables or the 4 variables what we have called, and for that you will get the value. Why this is important is sometimes when you have to do the grouping of the data, okay, and you want to analyze how this particular data is functioning, you have to do this particular long format conversion, wide to long format conversion, or sometimes you will have only long format with you, that to better analyze it, you have to convert into wide. Okay, so for wide format, for this particular conversion or reshaping of the data, you use this particular melt function. Okay, so now I have created the melt function. Now it's very easy for me now to create a comparison plot. Okay, let's see how the comparison plot is looking like. Okay, so okay, you can see here there is now I have the date and time in the y-axis. Okay, date and time in the y-axis, and I have this particular only for one day. How my load is changing, that is load 1, and how my load 2 is changing, and how my inverter input is what is this? This is load 2 energy, and in the middle is my inverter input. Okay, how my inverter input is changing. Okay, this is how you can just see it. But I purposely introduced this inverter output here. You can see here it is almost flat. Okay, almost flat. Okay, what does it mean? Okay, purposefully we have done it. Okay, why this is done is see how you will how if say you are having an production in energy. Okay, the solar energy is getting produced, but it is not consumed by your load. How you will come to know? Only if you compare what is the input energy, what is coming inside the inverter, and what is the output energy. Only then you will be able to consider it. Second is this inverter is connected to a battery. Okay, so if the complete energy what that solar power plant is producing is consumed by the load, then will you have anything to store it in the battery? You got it? Okay, so that is the reason I just put that particular output energy also. So why this is important is when there is an excess energy production, we have to store it inside the energy inside the battery. This haven't happened on this particular date, which is December 12. But this is not the case everywhere. There are some places where the storage also will happen. We will see in the subsequent codes. Okay. Now, what I want to see now is now I understood how my load is performing. Okay, sometimes my load is consuming the entire part of my solar energy production. It is not leaving anything to my battery to get stored. Okay, so that is one very important point what I understood from this particular data. Okay, now let me calculate the energy consumed and generated at a day level, each and every day, how it is getting generated, okay, and how it is getting consumed. Okay, so we have seen for one day. Now let me see it for the entire thing. Okay, for that what I am doing is I am creating one more data. Okay, like I'm using these are all as a temp variables. Okay, the new same I have used in the past also. Same pipeline function I am using. Okay, I am taking the data. Okay, using the pipeline function, I am grouping it with the location and date, and again seeing what is my solar energy production, what is my load 1 energy consumption, and what is my load 2 energy consumption, and what is my inverter input energy consumption. So everything I am seeing it. Okay. Now let's now see a cumulative sum of it, or I sum like load 1 energy, how much it has consumed, load 2 energy, how much it has consumed, and how much is the inverter energy. If I sum all these things, that gives me an indication of how much is the production and how much each and every load has consumed and how much is stored inside the battery. Okay, so that is what I am going to do. Now I am summing all these things. I am creating a plus and I am creating a sum of it. Now the total consumption, how it is, this is something like this. Now I want to understand how my solar energy, how much is the total energy and how much is my total consumption. Okay, I want to see how much I am generating and how much I am consuming. Again, this similar what I have done in the past, same I am doing it. I am creating a melt function, and with that I am converting this particular wide data into long data. Then I am plotting it. Okay, let me see how it is. Not for one day, for the entire day I am doing it. Now you can see here the total energy consumption. We know that we have seen it in the last also. Okay, but there are some places where the load energy what is required is higher than what it is produced. Okay, can you see here? Okay, this clearly shows like the solar power plant or the capacity of the solar power plant sometimes is not fulfilling the need of the total energy consumption. Okay, and sometimes you can see here the total consumption is less, but the solar energy there is a good rise in it. So during this particular time, what it will happen? It will store the energy in the battery, and that can be used for the next day. Okay, that is what we are seeing here. But again, I am drawing your attention. Many people will think like this is a technical problem. Why you need data science for this? Okay, see, though it is a technical problem, there are a lot of variance here. The variance one is the weather conditions. Second is the load. There will be a variance, and there is a variance in the solar panel itself. Okay, how much dust and other things. So with this particular thing, we need to understand whether the solar power plant is adequately sized for the load requirement. That is the very important factor here. Now we understood like there is a gap between the generation and there is a gap between the generation and the consumption. Okay, how much is the consumption and how much is the generation? There is a gap. Okay, for bridging this gap or buffering this gap or to make benefit when there is a good solar energy consumption, we are introducing a battery and the energy is getting stored in that particular battery. Okay, so that is the next scenario what we have to analyze. Okay, so what we have so far did is we understood how the solar energy production is happening and how the data is. The data is an instantaneous energy. That means each and every minute with compared to the last minute, how much is the energy, the data is being put. So when we have to do an analysis, we have to create a cumulative sum, and we have created that particular cumulative sum and we have explored the data. And what we also saw is the load. Okay, how much is the load? That is load 1, load 2, and the inverter is also a load, right? So all these three things, which is a cumulative load, and the cumulative load we have compared it to how much the solar power plant is generating. Okay, how much energy the solar power plant is generating and how much is the cumulative load. This is what we have seen, and we also have seen there is a gap between the generation, which is the red here, and the consumption, which is the blue here. So there is a gap. Okay, and this gap has to be merged. There is a gap either on the positive side or on the negative side. Okay, now the next level what we have to do is we have to see how the battery is compensating for this. Okay, so now we have seen how the generation is solar, we have seen how the consumption is, which is the load, and now let me see how the battery is performing. Okay, now I am splitting data with respect to only battery. Okay, I'm not taking that particular data set of 12, December 12, 2015. I am taking a different date, okay, where we are able to see the variations. Okay, so now what I'm subsetting is the battery related parameters. I'm subsetting and I'm creating a graph out of it. Okay, let me see how it look like. Okay, so this is how the battery power is, and this battery power in this particular date. Let me go to that particular date. January 31. So 2016 January 31. Can you see somewhere here? Okay, somewhere here. Okay, this is the place what we are going to investigate now. Okay. Now the battery power with respect to time we have seen. Okay, which is this particular graph. Okay, this particular graph, and let me see how the voltage across the battery is also there. Okay, you can see the voltage across the battery. There is a variation. Okay? There is a variation. Sometimes it is improving and sometimes it is dropping. So when it is dropping, that means like there is a consumption happening, and when it is improving, that is it is a charging. Okay, that is what we can understand from it. And let me also see how the current is. Okay, current is directly proportional to how much the generation from the solar power plant is. Okay, solar power plant is. So because that is the only source where how the energy storage is happening. Now we understood how this battery consumption is, how the battery current is, and how the battery power is. Okay, and it is directly proportional across the consumption patterns. Okay, so let me just compare only these two graphs. Okay. So I'm just taking a snippet of it so that we can compare. Okay, so you can see here. What is happening from here 6 o'clock to evening 6 o'clock? You are having the charging, right? Okay, during that time, can you see the rise in the battery voltage? There is a rise in the battery voltage. But if you see in the morning, okay, you can see there is a drop in the battery voltage. That means there is a consumption happening. There is a consumption happening, and you can see here there is a rise, which is the charging. Okay, so because of that, the battery voltage is getting increased. It is correlating with the current what you are seeing here. Am I right? Let me just overlay this. Okay. Okay, you see here there is a rise in the current, which is the charging, and during that particular charging, the battery voltage is getting increased. Okay, so this is something which we understand, and this is normal. But anyhow, with the data also we need to understand this. Okay, now we have did an analysis of how this is. Okay, so now let me go to the load side. Okay, let me take only the load one. Okay, only the load one, and we will do a small analysis of how this particular load one. Same thing, I am melting the data. That means I am converting the wide format into long format, and I am plotting. Okay, how it is. Okay, so load one, study of load one. Similarly, we will do it for load two also. Okay, study of load one. You can see here what is happening. Load current one. Okay, load current two. Okay, there are two load currents. One is the load 2 current is almost stable. That means the consumption of load 2 is almost stable. There is no variation. But load 1, it starts maybe at early 5 o'clock. Okay, and after that it is there in peak, or there is a high consumption till some say 7 o'clock, and after that it is coming down, and then it is increasing in the afternoon, and then it is coming down, and it is there in the evening. So this clearly shows like there is a human activity. The human activity will be there in the morning, where you will be having some people waking up. Maybe the person of this particular home, he is a 5 a.m. club member, and he is starting his exercises at 5 o'clock, and he is running all the appliances. Probably, I don't know. He is consuming a lot of energy, and then he is going out to his office, and then in the afternoon, maybe someone is coming inside and doing some household work. Okay, vacuum cleaning and other things, and then it is there in the evening also. The till in the afternoon, between 12 o'clock to 6 o'clock, there is no energy consumption. That means no human activity. And in the evening again, the person is coming back and he is using the energy. So this is the day curve. Okay, load day curve. Okay, so typical load day curve. Now let's see. We have seen the current. Let's see the power. Okay, obviously it will be the same. Okay, so yeah, it is the same. Nothing different. Okay, you see here now it is power instead of current. It is power. It is the same. Okay, so this is only doing an exploratory analysis of how it is. Okay, now let me see the inverter side. Okay, let me concentrate more on the inverter side. The inverter power. Okay, only the inverter power. Let me see how it is. Okay. So you can see here the inverter power is rising up. After that time, there is no power. Then it is rising up. Then it is rising up. Then it is rising up for some time, and there is a charging in the okay, before 6 o'clock. Okay, this is very obvious. Like when the load current of load 1 and load 2 is less, and there is a generation in the solar, then it is charging it. Okay, then it is charging it. Okay, so the input energy or the input power to the inverter is high during off peak hours, when the load is not consuming energy. During that time it is so this is also, we know that. Okay, and just we are validating. Okay, just we are validating. And now let me create one more feature, which is the with respect to some threshold. Okay, if the load current is more than 5 and the solar voltage is more than 150 and the solar power is more than 1000, okay, how the difference is. Okay, so I'm just creating it. Why I'm creating it is just to see how the peak loads are. Okay, I'm not so concerned about the normal load. I'm concerned more about the peak load. So I'm filtering when the peak load is happening, and I am creating a column, okay, which is A, and again the same thing I am doing it for one particular date and time, okay, then I can explore the data in a much better way. Okay, that is what we are going to do in the subsequent slides. Okay, so I'm going to see how this particular data is going to change with respect when I am having a peak. Okay, so that is what we are going to see in the next thing. Okay, and after this, I am diagnosing if there are some problems. The problem here is whether the solar power plant or the rooftop solar power plant is adequate for the load. Okay, whether it is adequately sized. Do we have to increase the size? That is the what we are going to see here, and we are going to statistically prove how it is going to happen. Okay, till now what we have done is we have explored the data, how the load is varying. Okay, when the peak consumption is happening, how it is, when the off peak consumption is happening, how it is. So this is the diagnostic information. Okay, so this is the diagnostic. So because the problem here for me is how whether the solar power plant is adequate for my load. That is my problem area. Now I have to understand how what are the variables for it. One of the variable is the load pattern. So I am seeing the load pattern. I am understanding from the load pattern that load 2 is almost stable, but the load 1 is having a variation with respect to I would say the time when a human activity is there. Okay, that is how the load pattern is looking like. Okay, so with this understanding, now I am ready. This is the reason why the problem is happening. Now I have to understand whenever there is a peak, okay, whenever there is a consumption of power, what is happening. So I have to split the data over a threshold. I have to split that particular data, and then I have to start creating the model. Okay, this is what we are going to see, and we are going to in the next session, what we are going to do is we are going to predict whether the next day whether I can run with this particular load pattern with the solar power plant itself. Okay, so that is what we are going to see in the next session. I'm going to predict whether the energy what I'm going to consume with that particular solar power plant is adequate for my next day's consumption. Okay, that is what we are going to see. And in between, we have the battery power. Okay, that is how we are going to see. Okay, till this particular thing, I'm like always, let me copy and paste this particular code so that you can also explore it. Okay, okay, any doubts so far? And also what I'm going to do is I'm going to share this particular workspace with you. If you have some, okay, so I can share this. Okay, this is also possible. So for this, what I request is please register. So whomever have registered with that particular name, we will share this particular project also, so that you can also explore how this particular project is there, what is the variable with whatever I have done so far. Okay, the same project, what I'm seeing, same you can also see. So when you are logging in. So what I suggest is you will receive this particular link very shortly in your email box for whomever who have registered. If you haven't registered, please register so that you can get a link of this particular project. And next thing what we are planning is we are also going to give you some assignment in the cloud itself. So you can also submit the assignment in the cloud, and from there you can have it. Okay, normally how it will look like is you will get the link of this particular workspace. Okay, and then you can come inside, and you can modify whatever you want. You can run the code. That is first thing. Okay, and you can see whether the same result you are getting it. Okay, and that is something which you can do straight away. And you can copy this code. Okay, you can copy this code into a new workspace. This is your own workspace, and do some experiments. That is possible. Okay, so we will do the sharing. I will share this particular project to whomever you have registered for this. You will have only the write access, or sorry, the read access of this particular code, but you can execute the code and you can see it also. That is also possible. Okay, so till whatever we have done, we will share the code, not a problem. Okay, I have already shared it in the chat window. If you are having some doubt, you will also receive it in the email. Any doubts? Please unmute yourself. If you have some doubts, please ask. Gokul, I can respond to all of them. Will it be possible to whomever have registered?
Sorry, sir.
Can I respond myself, or I have to send it to you?
No, I have to send from this mail ID.
Okay. So what is the email ID I have to send? This one, right? IAEMP India.
Learning@IAEMP India.
Learning@IAEMPindia.on-Microsoft. Okay.
Yeah.
I'm sharing it. Please share it with the participants also.
Okay. Okay, sir.
So this is 2305-2020 session diagnostic. So colleagues, you will get it from the organizers very soon. Okay, maybe immediately, and you can use this and you can experiment it in RStudio Cloud or in RStudio Desktop. In both the things you can do it. And we will share you the link also for the assignments, especially for Banariam Institute of Technology students with whom I think your staff wants to give you an internal mark based on this. Okay, any doubts so far in the chat window? Anything is there?
Participants, you can join to this WhatsApp group also. In that group also, we'll be sharing activities and this comments, everything. You can drop me a message. I can add you in that. I'm just giving my number so that you can.
So I think there is a request for a registration link. Just a minute. This is the registration link. Am I right?
Which one, sir? Yes, that one only.
Yeah, that one. So this is the registration link. What you are seeing here, and you can use the registration link and please register so that your email IDs will be there and you will receive it. And Mr. Omkar, I'm not able to understand your question. This is data science related or energy audit related? This is regarding energy analytics. Okay, it is the branch of data science which talks about usage of data analytic tools for energy problems. So Omkar, you are there still? Okay, great, fine. Any questions? But I'm very unhappy, especially students from BIT. You have to ask some questions. Please be frank. I request Professor Sundar, kindly speak with your students. Okay, whether they are comfortable with this way of teaching, or if they want, I don't know. You have to suggest me if there has to be more interaction from your students, how we can take their things forward. Okay. For rest other people who are joining from Hyderabad, I don't know whether there are some MSc data science students from Krishnamal who is also there here. Okay, but thank you so much for participating. Kindly be in touch every week, 6:15 to 7:15. We will have this particular session, and this is the link for registering. Okay, and you can also join to the group. You can also join to the group directly. Okay, that link is also available in the chat window. Okay, for your things. Okay, thank you so much.
Thank you all. Thank you.